Hello students, today in this lecture we will discuss about dividing or indexing head. And this dividing or indexing head, it is the most important topic of this milling machine chapter. So now first let us understand what is the meaning of or where is the use of this dividing or indexing head. So this dividing or indexing head is a mechanical device used to divide the circumference or periphery of a job into specified distance or angular separation. Similarly, this dividing head rotates the workpiece through a certain number of degrees or a certain fraction part of a complete circle for graduating the part. That means, let us take an example. If on any of the workpiece we want to obtain 14 number of equal division. Suppose, let us take an example. On the workpiece we want to generate 14 number of teeth, and for that 14 number of teeth we must need to have equal distance between all that teeth. Then how one can obtain that equal distance between all that 14 teeth? So to obtain that equal distance on the machinery for machining operation, this type of dividing head or indexing head is used. So this process of dividing the circumference or periphery of a job into a specified distance or angular separation, this process is called as the indexing. And for this indexing operation, there are different number of dividing heads are available. So that dividing head are plane dividing head, universal dividing head and optical dividing head. So we will discuss about these different types of head in detail in our next slides. So let us discuss about first plane dividing head. Now as you can see, this plane dividing head consists of the indexing plate. Then this index plate has different number of slots available on it, and this index plate is directly connected to this spindle, and this spindle is connected to the workpiece. That means one end of the workpiece is attached to this dividing head. Now first of all, let us understand what is indexing plate. Now to understand indexing plate, let us have a simple view. Suppose one circular plate is available, and on this circular plate there are on its periphery different number of holes are available. So this type of indexing plate having different number of holes over its periphery from center towards the outer side, this type of plate is called as the indexing plate. And this indexing plate has given rotation using the lever or using the handle available at its end. So with the rotation of the handle, this indexing plate rotates. This indexing plate is connected to the spindle. That's why the spindle rotates, and the spindle is connected to the workpiece. That's why workpiece will also rotate. And the indexing plate available in this plane dividing head has 12 to 24 number of holes based on the requirement. So in this head only 12 to 24 equal number of division only obtained by using this plane dividing head. So suppose if one want to obtain maybe 48 number of slots, maybe 96, maybe 120 number of equal divisions on the workpiece, then how that equal number of divisions can be obtained? So that equal number of divisions more than 24, that can be obtained using universal dividing head. And this universal dividing head has similar arrangement to that of the plane dividing head, but it has two extra parts are available, that is worm and worm wheel. So these two extra arrangement is available, and which will help us to obtain more than 24 number of equal division on the workpiece. So simply just let us understand the working of this universal dividing head. So now as you can see on this plate, indexing plate has different number of slots available, and this indexing plate has crank available, and this crank is connected to the indexing plate through this crank pin, and this crank pin is inserted inside any one of the slot. Now when this crank pin is given rotation, and this crank pin rotates the indexing plate, and as this crank is directly similarly connected to the worm. So this crank and indexing plate connected to the worm, that's why this also rotates the worm. So first of all, with the rotation of the crank, indexing plate rotates, and as the indexing plate rotates, it starts rotating the worm. And this worm is connected to the worm wheel. That means this worm now rotates the worm wheel, and this worm wheel is connected to the our workpiece. So this worm wheel rotation gives rotation to the job or the workpiece available, and that is how this workpiece also rotates. So this is the basic arrangement that is available in the universal dividing head. But the most important point for this case is the worm and worm wheel attached over here, it has the gearing ratio that is actually 40 divided by 1. That means this worm and worm wheel has gearing ratio of 40:1. Now what is the interpretation of this gearing ratio? That means if this worm completes its 40 rotation, so after completion of 40 complete rotation of this worm gear, it is result into 1 complete rotation of the worm wheel. That means 1 revolution of worm result into 1 divided by 40 revolution of the worm wheel. So this is how the change in speed that is obtained using this worm and worm wheel, and this will help us to obtain different number of divisions on the workpiece that we will understand or we will calculate in our next topics. So we have discussed here mainly plain dividing head and universal dividing head and how they differentiate. So in simple words, this plain dividing head is useful for only 12 to 24 number of equal division on the workpiece, whereas this universal dividing head will be helpful for more than 24 number of divisions on the workpiece. And these indexing plates shown over here are available in standard number of sets, and these indexing plates available as a standard are called as the brown and sharp indexing plate. So standard number of holes available on this indexing plate are, first of all, there are 3 different sets are available. On first set, there are 15, 16, 17, 18, 19 and 20 number of slots are available from inside to outside. Similarly, on plate 2, there are 21, 22, 21, 23, 27, 29, 31 and 33 number of holes are available. And on plate number 3, the holes available that are 37, 39, 41, 43, 47 and 49. So these are the different number of holes available on the standard indexing plate. And as you can see, these all number of indexing plates and the holes available on it, you must need to remember it. And to memorize it, it is very easy. On plate number 1, you can see it is only a sequence from 15 to 20. On plate number 2, you can see from 20 onwards, they have only selected odd numbers, that is 21, 23, 27, 29, 31 and 33. The only number missing, that is the 25, because as we have available holes in the multiplication of 5, that is 15 and 20, so they will be helpful to generate more than this number in the multiplication of 5. So in this number 2, odd number of sequence only, neglecting the number that has multiplication of the 5. Similarly, in plate number 3, you can see from 33 onwards only, neglecting the number having the multiplication of 5. Odd number series 37, 39, 41, 43, we are neglecting 45, then 47 and the 49. So that is how, just memorizing these odd number sequence, you can easily memorize the holes available on the standard indexing plate. And this indexing plate will be helpful to obtain different number of teeth on the gears during machining operation. And to obtain this different number of teeth on the gears, there are different indexing methods are also available. So that available methods are direct indexing, simple or plain indexing, compound indexing, differential indexing and angular indexing. And these different indexing methods we will study in our further lectures. From our next lecture onwards, we will start discussing about direct indexing and simple or plain indexing. So looking forward to see you all in our next lecture. Up to then, thank you.